All right. So it looks like it's 3 o'clock. So I'd like to welcome everyone to the first of our webinar series. Today we're going to be talking about what's all the fuss about with ADAS. And, we wanted to put these together just because we've been getting a lot of different questions and different comments and things like that from the industry. And we want to help add a little bit of clarity. We've seen a lot of really great webinars and different things over the last couple of months that are extremely technical and get in there really deep. But we felt like there was a gap that we could help fill and kind of get the ball rolling with some of the basics and where you need to start, because if you don't have the basics down, you're not going to be understand the more complex pieces of the ADAS. So to start off, I am Scott Van Hooley. I have been with iCar for 10 years now, and my main role is managing the RTS team and also OEM technical relations. Prior to working at iCar, I was a collision repair tech and took jobs from start to finish. I've done estimating, so done a little bit of everything in the industry. And this is a topic that has been part of all of our lives for many years. It really started for me about 2015, 2016, where we started to see a lot of these ADAS calibrations. So we'll get into that in a little bit. And Bud, why don't you go next?
All right. My name is Bud Center. I am the manager of the automotive technical research and development for iCar, and been with iCar now for a little over, or I'm sorry, approaching 4 years. So I've been in the industry roughly 36-ish years. Started as a technician, spent the majority of my career in MSO leadership position, and also spent some time on the insurance side of the industry as well.
And I'm Jeff Poole. I work at the iCar Tech Center as a technical subject matter expert internally. I prefer Guy and Cube, but that's not an official job title, they tell me. So I go with subject matter expert. I worked in the collision repair industry since late 80s. Actually started working on cars before that, like most car folks, but worked through my career as shops and then joined iCar. Started teaching iCar classes part-time in the mid-90s, joined iCar full-time in 2006, and in 2014 I moved up to Appleton, Wisconsin to join the Tech Center crew. So welcome everyone.
All right. So Jeff, we'll start with you. How long have we really been dealing with ADAS? We've been talking about it a lot over the last few years, but when did it kind of get its start?
Well, I think about technology in the vehicles, and most of us have seen that evolution of the technology in the vehicles, where vehicles were rather, I'm going to call it simplistic. Back in the day, we started seeing anti-lock brakes and things like that come into the vehicles. And there were evolutions there with the anti-lock brake systems, and we got into stability control and traction control, and that brought more sensors and I'll say data inputs into that system. But the foundation of it was still that electronic braking system that enabled that functionality. And then somewhere in the, the 80s, somewhere in the late 80s, I started seeing a lot of the parking sensors. And I know most folks out there, they would see those ultrasonic sensors. And the key to a lot of this technology and a lot of what we're dealing with today is recognizing the different sensor technologies that are on the vehicle, and then kind of understanding from there, what's that sensor do, and what are the possibilities with that sensor. So we saw the parking sensor technologies really hit hard in the 90s, and we got pretty comfortable with them, and we still had our challenges here and there. What's important to remember about those parking sensors being ultrasonic sensors, they're like a ultrasonic, of course, is above our hearing spectrum, but it's not into the radio frequency spectrum yet. But ultimately with those, they're like little speakers. I know that some folks will criticize that kind of comment or that relationship I drew there, but they are essentially little high frequency speakers that emit sound and then listen for that sound echoing back. They're reasonably accurate at short distances. but they're not much good at longer distances. Hence the placement of those sensors around the vehicles that we see, allow some of the functionality of some of these systems beyond just the parking sensor system that we were used to for so many years. They're starting to bring that into some of the self-park systems, things like that. We go from there to the earlier radar units, if you will, and there were a couple different versions where we had the adaptive cruise controls that started showing up. And I know some of the higher end elite models, they started seeing those sooner in the 90s than later, but we started seeing more of those come into the population in the late 90s, early 2000s. There were some radar units and some laser distancing devices, not full-on LiDARs, but laser distancing systems that were out there. And again, those were still pretty few and far between. But as time went by, and as with all technology, as it becomes more affordable, they can package these units on more vehicles, and that brings us up to the I'll say the 2010, 12, 15 era, where we started really seeing a lot more of this come into the car park population out there, to where we are today with so much technology in there. And what's important to remember with the different sensor technologies, the radars, they're emitting signals that are transmitted out and then reflected off of objects and vehicles in front. And then that reflected signal then is picked up and it's interpreted by the onboard logic, if you will, that's within that radar unit or within some other control module within the vehicle that then interprets that signal and then provides that warning or takes that action based on that reflected signal. Some of these radars have a rather wide field of view. Some of them have a rather narrow field of view. It depends on the particular application and ultimately what the vehicle maker and their supplier worked out. And as you look at the camera systems, again, we're seeing the camera systems on a very high number of vehicles today that then provide those eyes that are looking out in front of that vehicle that then allow that camera to collect data that's then interpreted through the onboard software that then allows the functionality of things like lane keep assist and in other cases object recognition. And as they start to bring the data from all these different sensors together, and this is where we start to look at what else can they do with these systems? And there's a lot on the horizon that we haven't seen yet, but ultimately it's that sensor data where you get a piece of data from one sensor and then they can correlate it to data from another sensor that really drives and reinforces the importance of the calibrations we're doing and the work that we're doing on these vehicles. And for me, it's beyond just the camera or the radar. What other operations are we doing on that vehicle that might, in some cases, not be interpreted as, I'm not directly working on the radar, I'm not directly working on the camera, but what other operations might we be doing as we get into suspension repairs, structural repairs, and things of that nature that then lead us back to, hey, you know what, there's something else that we need to make sure that we're checking up on and we're taking care of these calibrations and ensuring everything's going to work properly. I think back to the onset of the steering angle sensor, and that came in with the dynamic stability control systems and things like that. There's another data input. I look at some of the yaw rate sensors and accelerometers and things like that, the sensors that are within some of those foundational systems of stability control, where now they're leveraging some of the data from that's playing into some of these advanced driver assist systems.
So I know one thing for me that I saw quite a bit is when a lot of this technology came out, they'd see like a blind spot sensor and they would think that, why would they put a computer module outside the vehicle? That's dumb. And, a lot of the technicians just weren't aware of it because they're not keeping up to date on every little nuance of the new system that comes out, because a lot of times we look at it and it's like, okay, it's just another marketing thing. They're spinning it. And a lot of times collision guys tend not to look at a lot of that information, but we've kind of moved into an era where I think that's going to be more commonplace. We're going to have to pay attention and kind of decipher some of that information coming out on the new vehicles. Is it a kind of a new naming of the system, or is it actually a new system, or does it have new functionality? And I think that's one thing that we've kind of missed a lot in this industry, and one thing we have to pay attention to.
Absolutely.
Yep,
You know,
for sure.
that's something that I've always been the curious guy that whenever I'm taking something apart, I want to know, "Oh, what's that? I don't recognize it. I haven't seen that before." You know, and I want to know and I want to understand it, because we don't necessarily know the implications of that particular part, perhaps, and as it's related to whatever repairs we're doing or service we're providing on the vehicle.
So, Bud, what other types of calibrations are we doing for systems outside of ADAS?
Well, I think there are several, but some of the more obvious ones are probably things like the occupant classification system, or OCS. You know, there are many vehicle makers out there that require calibration following a collision, even if the system or the seat wasn't occupied at the time of the collision. So that's one. I think another example that we probably see quite often is when we're doing a wheel alignment. You know, the steering angle sensor in many cases requires calibration as part of that wheel alignment. And again, it's something we've been doing for years. And I guess another example is probably if you're replacing, say, an ADAS module or an ADAS sensor, there's often going to be programming required with those sensors. And that's very similar to the programming we've been doing for years as we're replacing other modules and things on the vehicles. So, you know, it's going to be different from one vehicle maker to the next. It'll be different from, you know, even within the same vehicle maker lineup from one vehicle to the next. So it's critical to always go in and look for the most recent vehicle maker service information, you know, obtain the latest procedures and identify things like, you know, required inspection items and calibration that are required following a collision. It's something that as an industry, we really need to get our arms around and make sure that everybody's out there doing this with every single vehicle we repair.
I was reading a technical service bulletin that was published by a vehicle maker earlier today, and coincidence about replacement of a backup camera. And in the replacement of the backup camera, evidently you had to go back and reprogram the head unit. I'm going to say the driver information center, i.e. infotainment center, the display, where they do updated software in there in order for it to then calibrate to that new. So it wasn't just a camera calibration. You know, you installed the camera, but then you had to update the software in that head unit in order for it to then provide the right picture, have the right view of the world.
Right. Right.
Well, and I think, you know, the other thing that kind of goes in with this topic is how interconnected all these ADAS systems are to traditional modules and things like that. If you don't have the ABS module working correctly, you know, how is that going to affect the automatic emergency braking? You know, so there's a lot of different things that we might not think about having an effect, and we might have to look up that repair information because for something that's as simple as, okay, we're going to take this module out and put a new one in, you know, collision techs are notoriously bad for, I can figure out how to take it out. I don't need the instructions. Well, now all of a sudden in that repair procedure, they will list out, oh, you also have to calibrate this sensor and this camera, and you have to do this. And so there's just so many things, even down to disconnecting the battery, what you have to do. So, you know, those are going to the OEM repair information has become so critical, and it just keeps getting more and more prevalent, and we keep seeing more of it. And, you know, we can't stress it enough. I'm sure everything you see come out, we're talking about OEM information, and there's a reason for that. It's just so complicated. If you don't have it, you're not going to be able to fix that vehicle correctly.
I think about chasing down bad grounds in the past, and sometimes I'd get a little frustrating on vehicles. Think about a bad ground on one of today's vehicles, and some of the challenges it can present if it's, I'm going to say, marginal and intermittent, introducing intermittent conditions. It can be a pretty interesting challenge out there.
Well,
Yeah,
and
that's for sure.
one of the other things that you know, I think we don't touch on enough is the diagnostics. Most of the time, your sensor is smashed, you replace it, the wiring's okay, no big deal. But if you have an issue, these systems are so interconnected. My favorite example was we had a vehicle that came in with multiple faults of all different systems, and we brought it into the mechanics. They did some tests, and the mechanic came back and said it needs a radio. I looked at him and I said, a radio? But the radio works fine. They said, yep, it needs a radio. Okay, well, we'll order a radio, and sure enough, put a new radio in there, and all the problems went away because that system went through the CAN bus, and there's a problem in that component, and so it affected everything else on that system. And it was the strangest thing I ever saw, but that kind of opened my eyes to just how important knowing what you're looking for is.
And there's a lot of that going on out in the diagnostic world. And I know the diagnostic technicians out there that are living this day in and day out. They have to be on their A game all the time and truly understand the topology of the networks, the communication networks on these vehicles. And as we move forward, that's getting, I'll say, more challenging as not all vehicles are the same, and there's multiple networks, and it could be something coming off of another network being fed through a gateway module or an interconnecting module that all it takes is communication signals to be off, and you've got a whole host of network codes and things like that. And sorting through all that gets to be an interesting challenge as well to find, okay, what's the root cause of all of this that's going on. And where it gets even more interesting is if there's, I'll say, more than one culprit out there that you're up against.
Right. I mean, it kind of all goes back to what we've been talking about for years now, the importance of the pre and post scan. Make sure you get out there, get that information, understand what the challenges are that the vehicle has when it comes into the shop, and then making sure that you've addressed all of those issues before the vehicle goes back on the road. So it's, we've been talking about it for years, but it's not going anywhere. We need to stay focused on it.
Yeah, and the pre and post scan, it was kind of interesting when that was the hot button topic. There were so many people that were focused on pre and post scan and overlooking all the calibrations and didn't understand that just because you did the pre-scan doesn't mean you're done. You have to go in and do your homework and diagnose what actually is wrong on that vehicle. And so many people were looking at it as a simple reading the codes and I'm done and I put it in the repair file. But you actually have to go in, figure out what system that is, go through the troubleshooting charts, figure out what's going on. There's obvious ones where the front radar is not responding because it's dangling off the edge of the vehicle. But then there's other ones that might be related to the accident, might not be related, but we still have to figure out all of that information. Yeah,
agreed. I mean, I won't go into the story because we heard it on the last webinar, but I've got firsthand experience with that in a shop that repaired my daughter's vehicle, and a shop that I trusted, that I knew very well, knew the owner for many years, and sent that vehicle over there. They first didn't do the scans. Then when I insisted they do the scans, they basically got back to me and said, okay, everything's all good. And I contacted the shop that did the scans and found out that they sent the vehicle over and just told them clear the codes. And when we did a little digging into what those codes were, one of them was actually tied to the clock spring on the vehicle, and the clock spring was bad. So we, it's something that we needed to address, and the shop was under the impression that they could just clear the codes and we were good. So.
Yeah, we hear that story all too often.
Yeah. So we'll move on to the next question, and I've got one for you, Scott.
All right.
What do you think the future holds for ADAS? For example, sensor technology and equipment requirements, stuff like that.
Well, I think you're going to see a lot more of the same. You're going to see, blind spots, and you're going to see all those different systems all working together. What we're going to start to see is a lot of the computer software and how it interprets the data coming in from those sensors. That's what's going to change the most. So we might not see additional sensor outside of LiDAR sensors, but I think you're going to see the capabilities of those sensors and systems expand and grow and become more advanced on the road to autonomy. And, they always talk about, I remember back in about 2015, they were talking about they were going to have fully autonomous vehicles by 2025. And we're not going to have a steering wheel in the car. Well, I don't know about you guys, but I think they've pushed back that date a little bit now. Once they discovered that it snows in places and it's not always sunny, in, like in San Diego and places like that. And so I think you're going to just see a gradual progression of all these systems, with LiDAR being the one that can really advance these systems the most because of the level of detail it can supply. But I think one of the things that I've been kind of hearing from a lot of the, engineering entities is that they have the sensors that are capable, but the computer programs and the computers can't keep up with the amount of data. Correct me if I'm wrong, but I believe I read one where there was over 1 million points of data from a LiDAR sensor a second. That was one article I read, and I thought, okay, we're picking up 1 million points of data and then interpreting that and using that data real time. Imagine the power of the computer that has to do that for multiple LiDAR sensors.
Right.
Absolutely. And behind the scenes, I've been reading about the evolving radar technologies, and some pretty interesting stuff that's happening there. And I'm kind of an electronics buff behind the scenes. Whenever it comes to this stuff, I enjoy reading about it and learning more about it. And so where that technology is evolving to where I'm going to say they can paint a better picture with radar. And that's not to say it's going to take the place of every other sensor technology out there. I don't necessarily feel that's true, but as they evolve the technology, they can actually, with a flat, what's known as planar array antenna. It's a flat antenna that I'll hold up one of them right here. That's out of a front radar unit. I don't know how well that shows, but basically they can steer the beam of radio frequency energy coming out of there, the microwaves, and then they can take and detect what angle did they send that signal out at, what angles are coming back at, what's the rate of closure, and things like that. And as they continue to evolve this technology, they can get better resolution, I guess, out of that. And that becomes pretty impressive to be able to bring that data together with, again, the camera data as they improve the cameras and as they take and perhaps bring LiDAR in to that picture more and more. They can then get the correlation of 3 or 4 different sensor, blending together to say, do you see what I see? And that correlation of where they gain the confidence to then evolve the system's capabilities.
Yeah, it's interesting because you talked, Scott, about the sensors staying much the same, yet you see all these new systems coming out on all the different vehicles. And I think it's important to point out the fact that the sensors themselves and the technology is really not changing all that much. You might have cameras that are improved or sensors that have improved range, but it's still a camera and a radar for the most part. It's more about the software behind the scenes that's running this technology and how they're using that information to drive these new systems on these vehicles.
Well, and I think we've kind of all gone through the ADAS revolution before, and that's when the airbags first started coming out. And nobody knew how to work on them or what they were all about. And it was kind of this weird voodoo thing that scared a lot of people. But over time, the systems kind of started to kind of standardize. We see the same thing in repairs where the OEMs have had to do a lot of interesting things with the structures to meet the crash resistance and also get the fuel economy they need. And so they've had to kind of experiment and try a lot of different methods. And I think you're going to start to see a lot of this calibrations and things like that start to kind of normalize a little bit. There's still going to be, procedures you're going to have to do. You're still going to have to pay attention to all this. But I think the variety, at least within the OEM, should start to lessen over time. That's not to say that LiDAR technology will change everything or some other technology will come out and it'll totally change how we do it. But as of right now, I think in the next 5 years, you're going to see a lot more of that kind of just level out and stabilize a little bit. Okay. So, Jeff, how do you know it'll work?
Oh, hopefully you take it out on a test drive. But I think about the confidence you build into the product you deliver to your customer. And that starts with every part of that repair, from disassembly to doing that pre-scan, making sure you've got the right diagnostics and repairs in process. You know, I don't think of it just as the ADAS piece. I think of it as the vehicle as a whole, and every bit of work that goes into that vehicle, from the structural repairs, the dimensional accuracy of the vehicle, suspension, and all of those pieces tying together. You mentioned earlier, and it's pretty common fact that you know, they are building better, safer cars today than they ever have. And I don't see that trend changing at all. Everybody wants the 5 stars, and guess what? I want to be in a 5-star vehicle too if I have an unfortunate mishap. But at the same time, I also want all the technology on board that vehicle working in my favor, and certainly not against me. So for me, I think about, you know, making sure we've got good documented processes in place for every aspect of the repair, including anything that has to do with ADAS or that's relatable to that in any way, shape, or form, in order that you know, whenever that vehicle's done, we know we've done everything that we can within our power as a repair industry to ensure we've given that vehicle back to the customer, I want to say, in as built condition as best we can, taking into consideration that repairs are repairs, and if done properly, we should have the documentation to support that as well. You know, there's only so far you're going to do with a road test on an automatic emergency braking system. I'm willing to take it out for a test drive. Just sign the waiver and hand me the keys. But I hope everything works the way it should. Sometimes there's unfortunate things that happen, but hopefully, as we're out there, and this is what I think about, if I've done everything correctly, the system should operate as designed. And that's where I would just make sure that I have not introduced any unaccountable variables into that process as I put that vehicle back together, that somebody can come back and say later on, well, did you do this way? And, you know, that's a pretty simple yes or no answer that comes out of that. Some folks may differ with that, but ultimately, that's what I think about with this when I say, how do you know it's going to work? Well, absolutely. We're going to follow all the procedures. We're going to take it out on a test drive. We're going to evaluate it and make sure it's right. Again, perhaps not taking it out and trying to run into something deliberately to see if the automatic emergency braking works. But in most cases, you'll find that those systems, once you start getting comfortable with them, and I'm no different. I was also one of those techs that with the airbags, it's like, ooh, is this thing going to go off by itself? Well, after a short order of time, no, they weren't just magically going off by themselves. And, you know, airbag systems, the only way you're really going to know if they're going to work is probably go out and run into something. But we've got the confidence that we've run the diagnostics. The system is proven out electronically. We've taken it out and we've done that road test. We've ensured all the calibrations are done, and we can hand the vehicle back to the customer with confidence that things should work as possible, as appropriate.
I have to say, I know that we're starting to run long here, but I have to. We're talking about the collision mitigation braking, and you guys know that we go out and spend a lot of time with industry professionals and doing research when we're writing our courses. And I got to tell the story. We're out at a location, and the company we were working with wanted to show us what happens when the mitigation braking isn't working right, and they had a foam target that they set up in the vehicle. They thought that the vehicle was going to stop. The vehicle didn't stop. It hit this foam target, and it punted that thing. It had to have been 300 yards across the parking lot. So it was just another example of, okay, hey, we need to make sure that stuff's right, and we really can't test that one without that type of target, because if they hit anything else, they would have destroyed the front of that car. But it was interesting to see that thing go flying across the parking lot, and yeah. Just something worth considering, picking up one of those targets if you're going to do that type of repair.
When calibrations go wrong.
Exactly.
Well, and one thing that I always point out to people is when we're doing anything that on a vehicle today, it's the small things that you have to pay attention to. How many times have you guys seen where somebody says, well, it takes an alignment, but it's still eating tires? Well, I can tell you right now, there's something wrong in that structure, and your alignment angles aren't correct, and it'll be green, but it's going to eat tires. Well, that's why. There's something else damaged, something else bent. that you didn't find. And with ADAS, it's even more critical. If you're just a little bit off because you got the structure kind of close and you just use a tape measure instead of three-dimensional measuring some of these systems or the vehicle structure, it's not going to work the way you intended.
Yep.
And we just had a question that came in. How do we know when a rear blind spot system needs to be calibrated? One place to start would be the RTS website. We have the calibration, OEM calibration search. And on that page, you can find out when calibrations are required, but that's going to direct you to the OEM repair information. So we'll tell you if there is no calibration event required. Ford is one that is a typical one where they only have you program the module from the previous module if you're replacing it, but it's basically plug and play. And that's kind of true for a lot of these different systems and sensors. You have to look at that repair information to know, because some are plug and play, some need an operation check, and some need to be calibrated. So there's no magic bullet to help us with that.
Nope, you're right. The only thing you can do is go to the OE procedures and see what they tell you to do.
There's another question up there. How do we know if ADAS recalibration was successful? So that's something that is, I'll say, unique aspects with each, I'll say, vehicle make or model or whatever is applicable there. But ultimately, as you're doing the calibrations, you're basically using your scan tool and saying, hey, go into calibration mode if it's a static calibration, and it's looking for that target. Now, it doesn't necessarily know if that target is positioned perfectly correctly, but if that target is somewhere out there within its field of vision, again, it's going to vary on what the tolerance of that system happens to be. And I'll reiterate what I mentioned at the last webinar that I did. Vehicle makers do not give tolerance on their target positioning. They give you coordinates, they give you specifications of where that target should be. And so ultimately, if it recognizes that target out there in front, says, yep, I see you, it's assuming you have put it where it's supposed to be. And now if you put it way off in left field or something, in many cases, the system will be smart enough to know that's not possible. It can't be way over there. But that's a validation then, where that scan tool typically give you some results back. In some cases, a scan tool might give you results back on a radar unit of an adjustment or a deviation or something of that nature, or even on a camera unit, some sort of information back as to how close it is to specification. And similar on a dynamic calibration where you're out on a road test, typically it will have some sort of a progress update on the scan tool for you to take and monitor, or have a second technician monitor as you're driving down the road safely, paying attention to traffic.
Yeah, I mean, to your point, Jeff, there, the sensors and modules aren't necessarily smart sensors. They assume that you've got that target in the right spot, and it calibrates to that spot. And while you're looking at the sensor, or I'm sorry, the target, and you're setting it up, you might think that something as little as a degree isn't a big deal, that it's just 1 degree. But when you take that out into the vision, the field of vision for that sensor, you get a couple 100 feet out, it could be enough that now the camera's not seeing the proper lane anymore, or that blind spot sensor isn't seeing the vehicle or obstacle coming up in the blind spot. So it's mission critical that these calibrations are performed exactly as the procedures dictate, and when we set up these targets, that they're put in exactly the correct position.
All right. Let's see here. So let's see here. The next question that came in, which vehicle systems are, depending on which vehicle systems we're concerned with, what ADAS calibration kits should be purchased?
I would say there, again, go back to the vehicle maker and understand what their requirements are. I don't think we're in a position to recommend any calibration system in particular. But I would go back to the OEMs, the vehicle makers, and understand what their requirements are to make sure you've got the right equipment.
One thing I would add would be, that's really, it's down to a business decision. What vehicles are you working on? What systems do you feel comfortable working on? If you don't have the space to do some of these calibrations, there's no one size fits all. There's no kit out there that will get you every vehicle for every manufacturer. That just doesn't exist today. There's so much variation, and we really need to look at it on an individual basis for your shop and figure out what's going to fit for your business model. So, Jeff and Bud, what happens when you have a bad day and you have to say, "Hi, boss, I haven't had a bad day"? What do we do with that?
I think a lot of it we've already talked about. It's having the confidence that the repairs that you performed are accurate, the calibration is right. But then as you're out doing these tests and the test drives, making sure that you're alert, you understand how the system's supposed to perform, but don't just assume that everything works. Be prepared. Like I said earlier, if you get out on the road and you've calibrated a camera and it's even a single degree off, it may not be seeing the correct lane, for the lane departure system or a lane keep assist. That single degree makes a big difference. If we're thinking about things like radar sensors, if we've repaired, for example, a quarter panel where we've got a blind spot sensor mounted to that quarter, we need to make sure we're going to the vehicle maker service information to get the exact, measurements if they're provided. They don't all provide them, but to understand exactly where that sensor needs to be mounted so that when it's, shooting out and again, trying to, for its field of vision, that it's seeing the right place. So you're seeing those vehicles behind you, things like ultrasonic sensors. If we've got one that we've got a scratch on and we repaint the sensor, but the vehicle maker says, don't paint those things. There's a potential that we get the vehicle out and go to test the park assist, and the system doesn't work, or it doesn't work properly. Or even worse, we go out and we don't test these things properly, and we put it back in the customer's hands, and they're assuming all these systems are functioning properly, and it results in another accident.
Yeah, that's one thing that I think there's a lot of assumption out there that you can actually, the system will tell you when it has a problem with it. And a lot of these systems, they don't know that a sensor's been replaced. They're not, that sensor or camera, it's putting out a certain signal, certain voltage, and that's what the computer's reading. So if you go in and assume that it's going to tell you if there's a problem, that's not always the case. We actually, on the RTS website for the calibration search, we will list in there if it'll set a DTC or turn on a malfunction indicator light, because that was one of the things that so many people assumed is the system's smart and it'll tell you that there's a problem with this system. It's so advanced. But it comes down to ones and zeros, and as long as it's seeing ones and zeros, it thinks everything's good to go. So that's one thing that will help prevent you from having a bad day, is not assuming, like I said earlier, not assuming that everything is working because there's no lights on the dash. And
Right.
Those are for the consumer, not for the technician. That's one of the biggest things to remember with those.
Right. Again, we get out into the field quite a bit, and there was another shop that had a story about a vehicle that they were test driving, and it would just randomly slam on the brakes. And it turned out that the camera was so far out of calibration that it was picking up overpasses and thinking that it was a vehicle coming into the lane, so it would just randomly slam on the brakes. So I mean, it's being aware of those kind of things when you're test driving the car that can be the difference between going home or having a really bad day.
Okay.
There was one other comment there. Seems as though ADAS might be the start of the autonomous vehicle. And I think we've kind of addressed that, but So the sensor technologies, as they get enough sensor technology on there and the computing power to back it up and the confidence, and get past some of the, I'll say, some of the legal challenges potentially that are out there. Absolutely, they've certainly got the highway paved that direction.
And another question that came in: are you seeing any blind spot detection sensors calibrate successfully but still misaligned? Absolutely possibility. There's a lot out there where you set up your targets, if there's a calibration, and all it's doing is saying, okay, that is where I should be looking. If you haven't set those up right, if the sensor's not in the correct position, it's thinking that everything is there. And so you could have a calibration that will take, and it now thinks that whatever that target was a appropriate distance to just point the data point on the floor. It assumes that there was a correct size target in the correct location, and it also assumes that the structure is correct. So if you're not making sure that that sensor and the structure is correct, you very well could have a successful calibration and it's not actually calibrated correctly. And that's where it goes back to doing all those little things to make sure that you're not programming that system to think something that it's not actually there.
Agreed. I'm seeing another question in here too about does lighting have any effect when doing calibrations? And the answer to that one is absolutely. There are many procedures that are going to talk about reflection of light and things like that when you're doing the calibration. So the answer to that one is yes. We need to make sure we have the right lighting conditions when we're doing these calibrations.
Looks like the next one was first we have to be sure that the thrust, before doing an ADAS calibration, first we have to be sure that the thrust angle in the vehicle is in specifications. And I would say that is correct. And even though it may not be in the repair information spelled out, it's assumed that when you restore that vehicle to the correct structural alignment, if the structure is aligned, now your thrust angle should be correct as long as all the damage has been removed. And some of these repair procedures will call out that before you do the sensor alignment, you have to do a four-wheel alignment, make sure everything is correct there. Yep. But that varies by vehicle maker and model. But that's one of those little things that if you don't have that correct for the structure, everything else is going to fall apart after that.
Agreed. All right, so it looks like we're at that point where we're going to go ahead and wrap things up. If you want to learn a little bit more about some of the things we talked about today, a couple of the courses you could check out on the ICAR website is calibration of forward-facing cameras and radars, and calibration requirements for blind spot and park assist systems. In addition, the latest edition of the Collision Reporter magazine, the ADAS issue, is cover to cover all about ADAS, and there's some industry experts that are in there that talk about different things ADAS. So again, it's something for you to check out. It would be worth your while to take a few minutes to read through that article, or that edition.
Looks like we have one more question come in here. If a system does not throw a DTC for a sensor, what is the best fail-safe procedure for validating successful calibrations? I think the first place that you'd have to go is, again, the OEM repair procedure, because in there, if you have to take that vehicle for a test drive or operation check, you have to make sure that there might be specific speed requirements, mile requirements, and things like that. And during that operation check or that test drive, it may throw a code for a system, or say unavailable, or give you some kind of indication. But again, is that system, is it plugged in? That would show it might not turn on a light, but it should throw a code for something like that. And you got to make sure all those little things are working properly, because otherwise you're not gonna be able to insure anything if you haven't done the basics right.
There's another comment down there about warnings about ADAS sensors emitting radiation when turned on. So the radars do transmit microwave frequencies. Some of the earlier ones were in about the 24 gigahertz range. Most of the newer ones are running up around 77-ish. I would not spend a whole lot of time in close proximity to them, just as a personal safety precaution. If you're a few feet away, that's not an issue. And I know I've seen numbers from some of the OEs, and I'm not recalling what they are, but they're relatively short distances. But you don't want to sit there with your head right up against the daggone sensor while the system's turned on. That's just not a good idea. Now, that's specific to the radars. Cameras are just cameras, and cameras are picking up light coming into the camera. They're not emitting anything per se. LiDARs, and there's only a couple of vehicles out there with LiDARs, and they're generally using an infrared laser light spectrum at that point in time that we don't see. I still wouldn't make it a habit to sit there and force my eye into the system while it was functioning. But
so I have one shameless plug for the RTS website here. If you have questions on ADAS and anything else collision repair related, check out the Ask iCar, come to the RTS website, and it's open to the public right now, so you don't need a login. And on there you'll find a lot of information about kind of why you should be training, and we have a lot of articles that'll highlight some of these different nuances of ADAS calibrations and just the systems themselves. And then on those articles, we'll also have the iCar course that can help you learn more. So if you're really interested in that article and you want to learn more, because they're just really informational to get the word out there about different topics, but to actually do the work, you need to go to the iCar training course, and that can help kind of build your training path for you of the information you need to learn right away. And there's just a huge wealth of information on that website, or so I'm told.
Agreed. Great website, great resource for the industry.
All right. So I guess that's a wrap for this one, guys. And then we'll see you on the next one in a couple weeks.
Yep. The next one is June 30th. It is where to begin with ADAS. Then we've got one July 14th, ADAS and OEM service information. And July 28th, get your shop ready and be prepared for ADAS repairs.
Thanks, everyone.
Take care.